Okay, so in this first video, we want to do a quick review of infusion rates that we've seen thus far, and then we're going to compare that to the types of situations that we are going to see moving forward with infusions, specifically the ones where we need to consider the strength of the IV bag that we're using and the medication that's in that IV bag. So we have two infusion rate calculations here on the page. First one is asking you to set the infusion for 250 mLs over 4 hours and 40 minutes, and we're setting that an infusion rate for an IV pump. So we are asked to convert that for an IV pump, which means we need milliliters per hour. The second problem is asking you to consider that same infusion, same volume, same time, but now what we need to do is to calculate a gravity infusion, so that means we need drops per minute. So I'm going to pause here. If you want to pause the video to try these two problems, please do. For both of these problems, we can approach it by considering the volume over the time. An infusion rate is a volume over time. And in this first problem, the total volume that needs to be given is 250 milliliters. The time is 4 hours and 40 minutes. We need to write this as 1 unit. Now, we could write this as total hours or total minutes, and I would encourage you to write this as total minutes because then we don't have to worry about rounding and perhaps rounding incorrectly. So I'm going to go ahead and just first turn those 4 hours into 240 minutes, and then I'm going to add those other 40 minutes to that. So this infusion will be running for 280 minutes. That is the infusion time. There are 60 minutes in an hour, so I multiplied that by 4, added those 40 minutes. So that means my infusion time, 280 minutes. This approach with starting with a volume over time is how we can approach every infusion rate calculation. Here's my volume, here's my time. Do I have the right units? I do not. If I stopped right now, I would have milliliters per minute. So that means I need to do a conversion with dimensional analysis. Specifically, I want to cancel out the minutes, so the minutes need to be in the numerator, hours in the denominator. I know there's 60 minutes in 1 hour. Taking this approach, where we are finding the minutes and then going to convert that into hours, allows us to avoid having to worry about a decimal in the middle of the problem. So now I'm going to have 250 times 60, divide that by 280. We should get 53.5714, and with an infusion pump, we're going to round this to the tenths place. So this would be 53.6 milliliters per hour. For this second problem, if you didn't already do this, go ahead and pause the video, attempt it on your own. I'm going to do the same thing. I'm going to start with a volume over time, but specifically, I want to know the total drops over the total minutes. So let's find the total number of drops from this infusion. We can divide that by the total number of minutes. We already know the total number of minutes. We calculated that in the previous problem. This infusion is running for 280 minutes. The total drops, we can calculate that by taking the 250 milliliters, and we know each milliliter is going to be broken into 20 drops. The tubing is 20 drops per ml. So that means each milliliter, if I take 1 milliliter, each milliliter will be broken into 20 drops. So we can multiply by 20, and we should get 5,000. There are 5,000 drops in this bag. With this tubing will break the 250 mLs into 5,000 drops. So now that we have our volume over time, we can go ahead and do that division. 5,000 drops over 280 minutes. Those are the units I want. We get 17.857, and then that continues. And because this is drops per minute, we're going to round to the nearest whole number. This will be 18 drops per minute. So in both of these problems, what we should notice is that we are calculating rates as a ratio of volume over time. Volume over time. If we know the volume, we know the time, we can put those together. If they're the right units we want, we can do that division. If they're not the right units, then we can use our dimensional analysis skills to turn those units into the ones that we want. Now, this is a review of the infusion rates we've seen thus far. As we move forward, we're going to be given situations and be put into clinical scenarios where we don't necessarily need to focus just on the volume of the bag. And what I mean by that is we need to not just focus on the volume, but also what is in the bag, the concentration of the bag. So if we scroll down here with our notes, how are the IV calculations that we're about to see in the videos here going to be different than our previous infusion calculations? So first, we're not just focused on the volume. We are also focused on the mass or the concentration of the medication in the bag. So we need to consider the concentration of the bag. And that means not just the volume, but also the chemical composition. So what's the mass? Oftentimes that's grams, or maybe there's a certain amount of milligrams of the medication in the bag. Sometimes there's a certain amount of micrograms. Not only that, but we're going to have a few new units that we'll see. So, some units that we'll see, milliunits. Milliunits are used for measuring synthetic hormones. So with oxytocin, pitocin, these are synthetic hormones that are used in the labor and delivery process. And a milliunit is the unit that we will see with that particular drug. And as the name suggests, a milliunit is very much related to just a unit. And it is related to that just as a milligram is to a gram or a milliliter is to a liter. There are 1,000 milliunits in one unit. So the prefix milli is the same as it has been all semester. There are 1,000 milliunits in one unit. The other set of units that are going to be new for us are milliequivalents. Milliequivalents, abbreviated MEQ, these are used to measure electrolytes. So we will be giving electrolytes every now and again, and we need to consider the rate in which the patient's receiving the medication or receiving the fluids, and then we may be interested to know how many milliequivalents of that particular electrolyte they're receiving per hour or per minute, or whatever value of time that we're interested in. So this is how the infusion rates that we'll see moving forward are a little bit different, how they're going to be new. They're going to incorporate the mass of the IV bag, or the mass of the medication in the IV bag, and they may also incorporate some of these new units. But they are going to be a little similar in that we need to identify the mass and the volume on the IV bag. So when we're converting between mass and volume, just as we have throughout this semester, with previous calculations, with oral dosage calculations, with parenteral dosage calculations, we use the strength of the medication that's available. That's exactly what we're going to do now, except the strength of the medication that's available is going to be an IV bag rather than a vial, or rather than a bottle of oral medication or some tablets or capsules or a vial for an injection. We're going to have to convert between mass and volume. They'll require us to interpret the medication, so interpret the IV bag, and use the strength of the IV bag. And so identify and use the strength or concentration, just as we have seen this semester. Okay, so last thing we want to do, I'm going to give you a moment here as we scroll down to these three bags. I would like you to write the strength or the concentration of each of these bags as a ratio. I'm going to continue here, so if you want to pause the video, write them as a ratio, please do. The strength or the concentration is going to incorporate the volume of the bag and either the mass of the drug, or if it's a milliequivalent, or if it's a milliunit, those types of things, units, we want to consider the chemical composition that's in the bag. For this first one, we have 500 milliliters. That is the volume of this IV bag. And this IV bag has 30 units of oxytocin. So that means if we are considering IV rates and we wanted to be mindful of how many units or milliunits this individual would be receiving, we have to use that strength, that concentration in our conversion. For our second IV bag, we have 250 milliliters. That is the volume of the bag. And these 250 milliliters contain 2,500 micrograms of fentanyl. An equivalent ratio is provided right below there, 10 micrograms per ml. So those are identical. One is just the unit ratio. So both of these would be appropriate to use if we are converting between micrograms and milliliters, or if we're converting between any other units of mass and volume. Finally, we have this bag of potassium chloride. The strength of this IV bag is 20 milliequivalents per 50 mLs. We would use that ratio when we are converting between rates. That's the end of this video. The next video is going to go over a few examples, and then we'll have a few more examples and more practice.